The next section is about using the unit circle to evaluate certain trig ratios. We are going to ask you to memorize the values on at least the first quadrant of the unit circle and be able to figure out the other values of the unit circle. And really the key to that memorization is getting good at looking for patterns in the unit circle and using those patterns to make it a less daunting task. So the unit circle is a circle with a radius of 1. Our angles on the unit circle always start right here. So this is the initial side of the unit circle, the initial side of the angle, and then the angle can end anywhere within that circle. And some values that are important to know about is that 0 radians or 0 degrees is in that right hand corner, and that since all the way around the unit circle is 2 pi, halfway around is going to be pi, and a quarter of the way around is going to be pi divided by 2. I think one of the things that is a challenge is that a quarter of the circle is really pi divided by 2, and that can be challenging to remember. But just remember that 180 degrees is pi radians, so that's halfway around the unit circle, and all the way around is going to be 2 pi radians. These ordered pairs, because this middle of the unit circle is 0, 0, that's the origin, and the radius of the unit circle is 1. If I step 1 unit to the right, I get 1, 0. If I step 1 unit up, I get 0, 1, and so on. So those values on the unit circle are very important to understand where they're coming from. The next set of values that it's important to understand kind of form a short, fat rectangle. This rectangle is, all of the values on this rectangle have the same coordinates, except for their signs are different. Just like in this situation, all of these coordinates are the same, except for their signs. And when we step out to this rectangle, all of those points also have the same values, but different signs. The reference angle for all of these angles is 30 degrees, or in radians, that's pi over 6, because 180 divided by 6 gives you 30 degrees. The other point on this rectangle is going to be 30 degrees less than pi. So this angle is 30 degrees, and that's less than going all the way to pi, or 30 degrees less than 180 degrees. The next point is going to be 30 degrees more than 180 degrees. And then the last one is going to be 30 degrees less than 360. It's supposed to be 30, but my handwriting is bad. And notice that all of these radians are over 6 because they all involve 30 degrees. This one is pi over 6 less than pi, which would be 6 pi over 6. So pi over 6 would be less than that, would be 5 pi over 6. This one is going to be pi over 6 more than pi, or pi over 6 more than 6 pi over 6. And this one is going to be pi over 6 less than 2 pi, which would be 12 pi over 6. Okay, so that's that rectangle. That's how we form that rectangle. Those are the angles that we're looking at. The ordered pairs are all the same at all of these points except for the signs. The first ordered pair is square root of 3 over 2 comma 1/2. I hope you can see that the y-coordinate is short and the x-coordinate is long. So that's one way you can remember that, long. That's one way you can remember that the x value is bigger than the y value for this angle. And then when I'm in the first quadrant, both of those values are positive. If I'm in the second quadrant, the x-coordinate is negative, but the y-coordinate is still positive because I'm still up high. If I'm in the third quadrant, they're both negative because they're both in the negative territory. That whole quadrant, every x and y coordinate is negative. And then in the fourth quadrant, the x coordinate is positive because I'm to the right of the y-axis, but the y coordinate is negative because I'm down low. So the long side is square root of 3 over 2, and the short side is 1/2. And then you just have to pay attention to signs. The next rectangle that we're going to look at is actually a perfect square. It's the reference angle for this one is 45 degrees. So for this one, this angle that is formed here is going to be a 45-degree angle, or in radians, that's going to be pi over 4. And the next one would be 45 degrees less than 180. So it'd be 180 minus 45, which is 135. Or it's going to be pi minus 3 pi over 4, or 4 pi over 4, sorry, minus pi over 4, which is why it's 3 pi over 4. And then this one is going to be 180 plus 45 and pi plus pi over 4. So that's why it's 5 pi over 4 and 225 degrees. And then the last one is going to be 45 less than 360 degrees, or pi over 4 less than 2 pi. So it's always this angle that gets formed with the x-axis that we're looking at as our reference angle. So this is what the reference angle is. It's the angle that's formed with the x-axis. So that's why we keep using 180 degrees and 360 degrees. The ordered pairs are the same again, except for the signs, and they're even the same as each other because we're 45 degrees out, so it makes sense that they would match. This ordered pair is going to be square root of 2 over 2, comma, square root of 2 over 2. In the first quadrant, they're both positive. In the second quadrant, the x-coordinate is negative because it's to the left. In the third quadrant, they're both negative because it's to the left and it's also down below the x-axis. And then the last one, the x-coordinate is positive because it's to the right of the origin, and the y-coordinate is negative because it's below the origin. The next set form this rectangle, which is a skinny, tall, skinny rectangle. For this rectangle, we're using the degree 60 degrees. So that again means that the reference angle that's formed with the x-axis, because it's always the x-axis, is going to be 60 degrees. And it's also called pi over 3 in radians. And then this one is going to be 60 degrees less than 180, so that's why it's 120, or pi over 3 less than pi, that's why it's 2 pi over 3. The next one is 60 degrees more than 180, so we go 180 and then we go a 60 degrees more, or pi over 3 more than pi. And then the last one is 60 degrees less than 360. For these angles, this is the reverse of the 30 degrees. The x-coordinate is small because this is the short side of that triangle, and the y-coordinate is big. So this one is small, that's why it's 1/2, and this one is big, that's why the y-coordinate is square root of 3 over 2. And again, in the second quadrant, x-coordinates are negative, but y-coordinates are positive. In the third quadrant, both are negative. And in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. Those are the values that you're responsible for on the unit circle. So when you're working on memorizing the unit circle, remember it's all patterns and that you're looking at signs based on what quadrant you're in, and you're looking at numbers based on which reference angle you're using. So that's how we're going to find those values. Okay. So when you're using the unit circle, the x-coordinate is cosine. And the reason that the x-coordinate is, the y-coordinate is sine, let's start there. Remember that the radius of the unit circle is 1. So if my point is x comma y, this would be the y value and this would be the x value. That's the same as the ordered pair. If I'm looking at SOHCAHTOA and I'm using my reference angle, it's going to be sine is opposite over hypotenuse. So sine is going to be y over 1. Cosine is adjacent over hypotenuse. So that's why that's x over 1. And then tangent is sine over cosine, so that's going to be y over x. And cosecant is going to be 1 over y. Secant is going to be 1 over x. And cotangent is going to be x over y because those are the reciprocal trig functions. They're just 1 over their partner. Okay, just a little note that as you're finding angles, positive angles are going to be counterclockwise, like this blue one is a positive angle. Negative angles would be clockwise. Moving around the unit circle in the other direction makes it a negative angle. You can describe every angle infinitely many ways, either by spinning around the unit circle a bunch of times or by going positive or negative, and it would still have the same trig values because you're just describing the same angle in different ways. Okay, so we can use the unit circle to evaluate the trig ratios. And I'll give you a minute to look through your unit circle and see if you can figure these out. And when you come back after you pause the video and try it, you can check your answers with me. So you're using your unit circle to evaluate these trig ratios. Okay, this first set, you're just reading values off of the unit circle or working towards memorizing those values on the unit circle. These are the answers I got for that first set. Cosine of 120 is going to be the x-coordinate at 120 degrees. Using that 60-degree reference angle, the x-coordinate is going to be the small one. Tangent of 300 is going to be 60 degrees short of 360, so the reference angle is going to be 60 degrees, and we're going to make a ratio y over x, or sine over cosine, and we get negative root 3. Secant of pi over 3 is going to be in the first quadrant, so it's definitely positive, and it's going to be 1 over cosine, so that's why it's 2. And then cosecant is going to be 1 over sine, 1 over root 2 over 2, because the sine coordinate is positive in that quadrant, and then we can reduce our radical to get just square root of 2. For negative angles, we're going to add 360 or add 2 pi in order to turn them into the positive angle so we can figure out where we're looking at the unit circle. Please note that sine of a negative angle doesn't necessarily mean that your answer will be negative. When we did sine of negative 210, we were actually at angle 150, and our y coordinate at that angle is actually positive. So that is a summary of how to use the unit circle to find values for sine, cosine, cotangent, secant, cosecant, and be patient with yourself, but look for patterns as you're trying to memorize these values, because finding patterns is going to be key to help you with that. All right, thanks so much. Bye.